Bluetooth is wildly popular for fitness trackers and wireless audio, but what about home automation? The devices in your home communicate using different protocols like Wi-Fi, Zigbee, MQTT, or Bluetooth. Each is designed for specific purposes. Wi-Fi is the most well-known. Devices connect directly to your router, so it's great for high bandwidth tasks like streaming video from surveillance cameras. But Wi-Fi devices consume a lot of power and can clog up your network if too many are connected. On the other hand, Zigbee is known for its efficiency. Zigbee devices form a mesh network where they work together to extend signal range and reliability, and it's really great for low-power devices. But it requires a hub like Home Assistant and a coordinator to manage the network. Bluetooth takes a different approach. Devices don't need an extra hub, they speak directly to each other. Bluetooth low energy devices are great for battery-powered devices because they use very little power. But Bluetooth works best for short-range communications, like for door locks, which means you're not going to see Bluetooth managing really complicated setups. Bluetooth isn't as popular as protocols like Zigbee for home automation, but that doesn't mean it's not useful. It is, for devices that need simple, close-range connections, like smart locks and temperature sensors. Stick around, I'll show you how to set up a Bluetooth proxy. Even if your Home Assistant setup doesn't have built-in Bluetooth, or you want to just extend the range, a Bluetooth proxy can help. A Bluetooth proxy listens for signals from nearby devices and relays them to your Home Assistant server over Wi-Fi. Think of it like a Wi-Fi range extender, improving the stability and reliability of your Bluetooth connections, especially for devices that are farther away from your server. Let's set up a Bluetooth proxy in Home Assistant using an ESP32. You'll need a computer with Python installed to flash our ESP32 board, a USB data cable, make sure it's capable of data transfer and not just powering on your board. There's lots of ways to flash firmware to your ESP32. If you're using a plain ESP32 board, I would try the ESPHome web installer. It took about 2 minutes. If you're using an ESP32 variant, like I'm using the ESP32C3, or you run into issues with your plain ESP32, we still have lots more options for setting it up. There's the ESPHome dashboard in Home Assistant. ESPHome also has a separate website called ESPHome Web. Those are both a little flaky with my setup, so I'll show you how to install ESPHome and flash your board from the command line. I'm using a Mac. This next part is similar if you're on a Windows or Linux machine, but you'll want to check your specific documentation. Let's start in our terminal window at the command line. Make sure you already have Python 3 installed on your computer. We'll make a new directory and move into that directory and set up a new virtual environment called Venv and activate it. And let's install ESPHome. Okay, if you run into a message like this just means you need to update your pip installer. And then try installing ESPHome again. And make sure that it installed successfully. Now that ESPHome is installed, let's configure the ESP32 board and give ESPHome instructions for how to communicate with Home Assistant. I'll include a link to my configuration if you want to use mine, but you'll need to update a few sections with your own details. So let's set up the configuration file from scratch. Create the new file and open it in your preferred code editor and paste in our configuration. This part is very important to make sure the ESP32 can properly read the firmware. And then you'll update your own Wi-Fi credentials and enable the Bluetooth proxy. Now we're ready to compile and upload our firmware. So connect your ESP32 to your computer with that USB data cable. And then we can compile and upload the firmware. You can pick how you want to upload it. When it's done, the ESP32 will reboot, connect to Wi-Fi, and establish a connection with Home Assistant. In Home Assistant, go to Settings, Devices and Services, and you'll see a newly discovered device. It might take a moment. You can add it to your dashboard and assign it to an area. And now we see it under the ESPHome integration. If you didn't have Bluetooth support or you had devices just out of range, you might see more newly discovered devices. Some tips for optimizing your Bluetooth proxy. The first is that placement matters. Make sure you're placing your ESP32 between your Home Assistant server and other Bluetooth devices to extend the range and improve reliability. Also remember, your ESP32 can handle other tasks like managing sensors or automations alongside its proxy duties. But keep in mind, relaying signals increases your power consumption, and your Wi-Fi performance might be slightly affected since the ESP32 shares the same antenna for Wi-Fi and Bluetooth. And that's how you build a Bluetooth proxy. Let me know in the comments below what you want to build next, and I'll see you next time. Bye.